right, we are now headed into the graphs of the other four trig functions. So we're going to first go with tangent and cotangent. So we're going to graph these two creatures. So tangent and cotangent, they have x-intercepts and they also have vertical asymptotes. And the curve looks like an x to the third. Curve kind of slides through that intercept. The only difference is that, well, not the only difference, but shape-wise, it's tangent is bound in between the two vertical asymptotes, and x to the third is not. Okay, and this curve just repeats itself over and over in both directions. Okay, so the first intercept is just like sine, it's at 0, and then it's at the whole number pi. So 0, pi, 2 pi, 3 pi, and so on and so forth. And then the vertical asymptotes are at like negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and then the negative versions on the left side. So why is that? Like, why do we have intercepts there, and why do we have vertical asymptotes at those values? Well, think about what tangent actually equals. Tangent is equal to sine over cosine. So when you set it equal to 0, that's how you would find your x-intercepts. Well, because it's a fraction, the numerator gives you the intercepts, but the denominator, that gives you your vertical asymptotes. So that's why they are where they are. So the intercepts of cosine are the vertical asymptotes of tangent, and the intercepts of sine are still the intercepts of tangent. So cotangent, it's actually going to flip around because now your fraction is upside down. Now it's cosine over sine. So we have a vertical asymptote at 0, and then pi, 2 pi, 3 pi, 4 pi, 20 pi, and so on, in the positive and negative directions. And then the curve is upside down from tangent. So your intercepts are now occurring at those odd number pi's over 2. So negative 3 pi over 2, negative pi over 2, positive pi over 2, 3 pi over 2, and so on. Okay, so the theorem is going to talk about what happens when there's a number in front of tangent and when there's a number in front of the x, or if there's a coefficient there. So for y equals a tangent of bx and y equals a cotangent of bx, the first thing to note is that there is no amplitude. Why is that? Well, think about what an amplitude is. It's the distance from the center to the top. Well, the top never stops. It just keeps going and going and going. So it's an infinite distance. The other way to look at it is, it's the max minus the min. Well, there's no max value, there's no min value. So there's no amplitude. However, there is a period because the curve does start to repeat the same shape over and over again. So for tangent and cotangent, the period is going to equal just pi over the absolute value of b. So same for sine and cosine, just take off the 2. Okay, so for tangent and cotangent, again, you're only going to graph it for one period, so that's only going to be like one of these x to the third type graphs, but then you have to label the intercepts and the asymptotes. All right, so the number in front, it's no longer telling you what the amplitude is. It basically tells you like how thin or how wide your curve is going to go. So the higher the value out in front, the thinner that your curve gets. But again, these are sketches, so you're not really going to see that unless you're like doing everything to scale on graph paper or you were using some sort of graphing utility. But for our purposes, when you draw them, you know, don't worry if it's too thin or too wide or whatever. That's not the point of these problems. The point of the problems is, do you have the right shape? Do you have the right intercepts and asymptotes? That's pretty much it. Okay, so no amplitude but the period. We have pi over the coefficient going with x, which is 1/2. So the period is 2 pi. So tangent is kind of interesting because we like to use that intercept at 0. We can anchor things down on 0 for curves. That's kind of nice. But then there's an asymptote on either side. So we know the curve is going to do that. We just got to figure out where the 2 asymptotes are. Well, to figure that out, just take the period, divide it by 2, and whatever number you get, that's how far out to the right you're going to go and how far out to the left you're going to go. So since you're moving to the left or to the right and to the left of 0, it's just pi and negative pi. And that's pretty much it. You can always do that for tangent, which is kind of nice. Okay, so let's try it again with this one, and then we'll stop the video. Okay, so the period, pi divided by pi over 2, it's going to give us 2. So if I take 2, if I divide it by 2, I just get 1. So that means I now know where my vertical asymptotes are going to go. It's just negative 1 and 1. And then the curve goes right in between. However, it's a negative in front of it, so that means it's upside down. Just like that. With an intercept right at 0. Okay, so there's kind of some basic graphs for tangents. The next one we'll look at some cotangent curves.